Hello, my name is Talton Kasky, and today I'll be talking about protecting Louisiana's lifeline by combating pipeline corrosion with advanced composite linings. Louisiana plays a critical role in the U.S. oil and gas industry with a vast network of pipelines transporting oil and natural gas across the state and into the Gulf of Mexico. These pipelines are vital to Louisiana's economy, supporting thousands of jobs and contributing significantly to state revenue. However, the state's coastal environment presents unique challenges. Louisiana's humid, salty air, along with their frequent hurricanes and tropical storms, accelerates corrosion in pipelines, especially in coastal and offshore areas. This corrosion increases the risk of leaks, environmental contamination, and costly maintenance, making it a pressing issue that threatens both our economy and our fragile coastal ecosystems. To understand why corrosion is such a critical issue, let's first look at what it actually is. Corrosion is a natural process where metals deteriorate due to chemical reactions with their environment. For pipelines, this often involves reactions between steel, oxygen, moisture, and salts, leading to rust and weakened metal over time. In Louisiana's coastal environment, corrosion is especially problematic as high moisture and salt levels from the Gulf of Mexico accelerate the process, making pipelines more vulnerable to damage. As corrosion progresses, it weakens pipelines, creating thin spots, cracks, and leaks. These leaks allow oil and gas to escape, posing serious risks to soil, water, and coastal ecosystems. Additionally, repairing or replacing corroded pipelines is both expensive and disruptive, causing financial strain and potential supply interruptions. Together, these environmental and economic impacts make corrosion a critical issue for maintaining safe and reliable pipelines in Louisiana. To address these problems, a composite lining offers a promising solution. This lining is made of an epoxy polymer matrix, chosen for its strong adhesion and chemical resistance, and is reinforced with glass or carbon fibers for added strength. The epoxy forms a durable barrier that blocks moisture, salt, and other corrosive elements from reaching the pipeline surface. While the fibers provide the strength needed to withstand high internal pressures, this combination of corrosion resistance and structural reinforcement makes the composite lining ideal for protecting pipelines in Louisiana's challenging coastal environment. Now, you might wonder why this wasn't used initially. When many pipelines were built, advanced epoxy polymer linings weren't as widely available or economically feasible. Traditional corrosion protection methods like basic coatings and cathodic protection were the standard. Today, however, advances in materials science have made high-performance epoxy and fiber-reinforced composites more effective and accessible, offering a level of protection that simply wasn't achievable when these pipelines were first built. Let's dive into the science behind this solution. Creating a corrosion-resistant lining for pipelines requires specific materials to ensure durability and protection. This composite lining consists of three main components: an epoxy polymer matrix, reinforcing fibers, and corrosion inhibiting fillers. The epoxy provides a strong, chemically resistant barrier that adheres tightly to the metal. Chapter 14 that we learned in class explains how its high cross-link density makes it tough and resistant to degradation, crucial for Louisiana's climate. In addition, the embedded fibers detailed in Chapter 16 reinforce the epoxy, allowing the lining to handle high internal pressures and resist cracking over time. Additionally, corrosion-inhibiting fillers like zinc or aluminum particles act as sacrificial anodes, protecting the steel by corroding first, a concept covered in Chapter 8 on corrosion resistance. Together, these components form a robust, multi-layered defense against both chemical and physical challenges in Louisiana's environment. So, how is this composite lining applied to existing pipelines? The process involves several key steps. First, surface preparation is crucial. Technicians use abrasive blasting to clean the pipeline interior, removing rust and contaminants. This roughened surface ensures a strong bond for the epoxy. Next, the epoxy and fiber reinforced coating is applied through spin casting or spray coating, creating an even, consistent layer. The embedded fibers add structural strength while corrosion inhibiting fillers like zinc protect the metal surface. Finally, the coating undergoes a curing process. solidifying the epoxy into a durable, impermeable barrier. Although this application process has some upfront costs, the long-term benefits in terms of reduced maintenance and improved reliability make it worthwhile. With this solution in place, we can anticipate significant long-term benefits. The lining extends the pipeline's life, reduces the likelihood of leaks, and cuts down on costly repairs, leading to lower maintenance expenses. Fewer leaks also mean less risk of environmental contamination, providing essential protection for Louisiana's ecosystems, including its wetlands and coastal areas. This proactive investment not only preserves critical infrastructure but also protects the environment, balancing economic needs with environmental responsibility. In the long run, corrosion resistant linings support both infrastructure resilience and ecological health.